Alright, day 651 off the grid. That sounds like the fire siren's just gone for its usual Monday night test. I spent the day gaylawning today. Looks nice again. Wasn't very long since last time I'd done it. That's Spring Grove. Oh, so the lighthouse has just come on. Nice. Anyway, I also did some work on the 10 volt battery bank, so we'll have a look inside and see. I simply moved those two large 150 amp hour AGMs from my outside workbench and put them here, as I was discussing I was going to do. Now I tell you what, it was a real brain puzzle trying to figure out how to get so many different sized batteries connected together while still observing proper corner to corner parallel connection. And I was almost thinking of abandoning that, but I didn't. I actually did it. So the first battery here is the main negative. Comes through this strap, up through here, through this strap, down through this cable, and finally to the last battery there. The main positive takes a slightly more deviant path. It goes through this cable here to that terminal, through this long cable, which is a little naughty, through this strap, then through there, and finally through that strap to that terminal over there. So that's obviously the positive takeoff and the negative takeoff there. Now, I wasn't too worried about cable resistance or anything like this with this 10 volt battery bank, because that brings us neatly to a point I want to say about a 10 volt battery bank such as this. You do not treat it as an ordinary battery bank. It's a 10 volt battery bank and it has different qualities. How does a battery get to 10 volts? Because one of the cells craps out. It either shorts out completely or it just goes dead. So that means that a lot of these so-called 10 volt batteries have quite a high internal resistance. So what that basically means is, although they cannot drive loads very well because that high internal resistance will cause the voltage to fall rapidly as soon as you put a load on it, they still store a substantial amount of energy. But the trick is how do you get the energy out of these batteries? Well, you can't do it in the normal way. You can't just connect them to loads and use it. You have to take the energy out of them slowly. And that's what I do. These are connected inside the shed to a boost converter, which you've seen, and what that basically does is slowly dribbles current from these batteries to the 24 volt bank in there. When I switch it in, of course, when I need them to do so. So what happens is, over a series of many hours, these batteries slowly transfer their energy to the other batteries. It happens at pretty low current. There is an initial current of about 15 amps when these guys are fresh and the battery that's receiving the charge is low, but that soon settles down and just a few amps in the end flow, but that can flow like that all night. So these do not run any loads directly, they just transfer their charge into a more suitable battery bank for running loads. So if they're treated like that, then they can store a substantial amount of energy, and obviously adding these two extra ones down here now, I've got even more energy stored. And likewise, the charging. I don't charge them fast, they just get some current dribbled in, no more than about 1.5, 1.8 amps, even when they're flat. And it doesn't take much energy from the main system, and over a period of time, it could be a couple of days, they regain their charge ready for the next time they need it. So they're an emergency bank. You can call on them occasionally. You obviously can't call upon them all the time, because once they're used, they take a while to recover. but it's a great way of putting what would be otherwise scrap batteries back into useful service. And I was actually talking to one of the guys that came out to Castle Point with a lighthouse engineer, and I was explaining this whole situation because he's a battery expert. It's what he does for a job. He goes around troubleshooting various industrial battery installations, and he understood this concept completely. He thought it was a great idea. Obviously in a commercial situation they would never do that, they would just buy new batteries, but when you're off the grid trying to save money, you don't just want to use these batteries for scrap, you want to get the most out of them, because they're still worth the same for scrap once they're completely fucked, you know what I'm saying? So yeah, he got the idea. You know, the key is that they can still store a lot of energy, it's just that they cannot output a lot of current. Well, they can, but the voltage falls. Yeah. So you still have to be careful with them, of course. Yes, you still have to be careful, because they can still make some big sparks and all that kind of great stuff. So as well as shifting these batteries over and figuring out the puzzle of how to wire them up, I also did a little bit of work on the charge controller itself. Look, gone's that dangling clip leads and that bulb. Instead, here it is. This is an outside garden light fixture I bought from Bunnings, probably for $1 or 50 cents during one of those super discount episodes that they often have. And although these normally take a little 5-watt bipin bulb, they will quite happily accept an MR16 pinned bulb, which is still a bipin as well. The pins are slightly fatter, but they go in no problem. This fixture is rated to handle 15 watts of lighting, even though the bulb that came with it was only 5. Of course, what am I doing here with a 50 watt dichromic bulb in here? Well, of course, this 50 watt bulb never sees its full rated voltage, so it never dissipates 50 watts of energy. In fact, it should stay well within the 15 watt rating of this fixture. And also, being a dichromic bulb, of course, it's got its own reflector, so a lot of its energy it's going to push out. It did come with this cover, which goes on there, which I may or may not put on there. I'll just see how warm it gets before I employ that. So that's a lot tidier. I'm just going to cable tie this lead, but that's a tomorrow job. It had some insulation displacement connectors in here, same as what they use on computer headers and stuff, but bigger scale. When you screwed the spike on it, you normally have a true rip cable which goes through there, but I found just 2 of these conductors side by side work pretty well. I've just put this little cap on the end here and filled it up with hot melt glue to stop any corrosion of the cables from this otherwise exposed end. I just hacked off the spike that would have gone into the ground to just leave this cap to screw up to do that. So yeah, kind of neat. There's my outdoor equipment setup. Julie and Eilert would be most impressed leaving electronics outside. Yeah, I thought that's kind of cool. I actually put the 2 extra screws in here that I hadn't put in to hold it onto the wall, because I haven't had to make any modifications to that. So without risk of this video getting too ranty, we'll just go inside the shed and show you the wiring in the inside. Well, I just simply installed this 10 amp circuit breaker here, jumped it across from this one, which is the feed from the main solar array, and run that brown cable which goes outside to the bulb assembly. So now I've got 10 amps. I could have probably done with a 6 amp one, but 10 amps is fine. These cables are rated for 10 amps, so no problem there. It's mainly just to use as an on-off switch, because obviously with something like a bulb resistor in series with a circuit like that, the current's limited anyway. And that's basically it for day 651. I just did a test before which took this down, but even at this time of day with the sky like this, it's still trying to climb back to its 11.5, which this circuit holds it at, which seems to be a good voltage for these 10 volt batteries to be held at. Haven't had any problems from it, not yet anyway. One last thing I want to show before I switch this video off. And yay, this video is going to be a video shot completely in cam, no editing. Butterfly nuts, Mickey Mouse nuts, whatever you call them. I've got a few on here, and I don't feel you can ever get them tight enough by hand for battery connections. So this is my little jig I use. Just use a 40mm set spanner for these ones, and something to work as a T-bar through the ring, and you just simply lock it up on the nut like that and turn away. I usually take the little plastic things off before I do it, because this will actually crease them or even tear them. But you just lock it on there, and that T-bar gives you lots of oomph, and you can get them really tight. I know you can buy proper spanners now to do that job, but why bother when that does the trick? And it does it really well. So yeah, my 10-volt battery bank, my really simple PWM charge controller, which keeps it sitting nicely at 11.5 most of the day. This resistance bulb here, which limits the power that can run through this circuit, but because it's a bulb rather than a fixed resistor, as the sun goes down it cools off, and it tries to maintain the current at a steady level as much as it can, so you get a little bit more out of it that way. I'm not really worried that because of this can actually take nearly its full current even on the cloudy days, where other circuits might be, of course, not getting their share they would normally get, because this is, after all, a backup battery bank for use on days when the weather is bad. So it's a good thing it's well topped up before we begin. So there we have it, day 651 off the grid.